There is a part inside your car's air conditioning system that almost no mechanic will ever mention to you. It costs between $10 and $18.
It takes less than an hour to replace with basic tools that you probably already own. And when it fails, which it always does, eventually, it causes your air conditioning to blow warm air, struggle to cool the cabin, and lose efficiency in a way that feels exactly like a much bigger, much more expensive problem. That is not a coincidence. What I'm about to show you has the potential to save you between $300 and $1,200 for the next time your car's AC stops working. But more importantly, it's going to change the way you understand everything you've ever been told about air conditioning repair, because once you know what this part does, why it fails, and why it's almost never the first thing a mechanic diagnoses, and you won't look at an AC service estimate the same way again. Let's start with a moment you probably recognize. It's the middle of summer.
The temperature outside is in the mid-90s. You get into your car, turn the AC to maximum, and wait, the fan blows, but the air coming out of the vents is barely cold.
Maybe it's lukewarm, maybe it starts cold and then gradually loses its edge after 20 minutes of driving. Maybe it never really gets cold at all. You press the recirculation button, you adjust the temperature dial, nothing changes, and somewhere in the back of your mind, you already know what's coming. The mechanic, the diagnostic fee, and a number with a comma in it. You've been through this before, or you know someone who has.
A friend who spent $800 on a compressor replacement, a family member who paid $450 for a refrigerant recharge, and a leak repair,
only to have the AC fail again 8 months later. Someone who got a quote of $1,200 at a dealership and decided to just drive without AC for the rest of the summer. These stories are not rare, they're practically universal, and almost every single one of them shares something in common that nobody in that repair shop ever bothered to explain. The real culprit in the majority of these cases was never the compressor, it was never a catastrophic refrigerant leak, it wasn't a failed condenser or a broken expansion valve. It was a small cylindrical component, roughly the size of a large can of soup, called the receiver-drier. And understanding what it does, how it fails, and why that failure is so consistently misdiagnosed is the key to everything.
Here's what you need to understand about how your car's air conditioning system actually works. The system is a closed loop.
refrigerant, most commonly R134A in vehicles made before 2021, or the newer R1234YF in more recent models.
It starts as a high-pressure liquid, passes through an expansion valve where it rapidly loses pressure and temperature, absorbs heat from the air inside the cabin,
and then gets compressed again to restart the cycle. It's an elegant system, and when it's working properly, it can drop
But this system has one critical vulnerability. It cannot tolerate moisture. Even trace amounts of water inside the refrigerant circuit are catastrophic. Water molecules react chemically with R134A to form hydrofluoric acid, one of the most corrosive substances known to engineering. That acid attacks the metal surfaces
of the compressor, the expansion valve, and the evaporator from the inside. It degrades seals, it accelerates wear on every moving component.
And the ice crystals that form when water freezes at the expansion point can physically block refrigerant flow, causing the system to behave exactly as if it's low on refrigerant, even when it isn't. This is why the receiver dryer exists. The receiver dryer is, at its core, a moisture trap, cylindrical shell. They're most commonly silica gel, the same substance found in those small packets inside shoe boxes and electronics packaging that say, "Do not eat."
The desiccant absorbs moisture from the refrigerant as it passes through, keeping the certain and chemically stable.
Inside the receiver dryer that captures particulate contamination, metal shavings from normal compressor wear, debris from deteriorating seals. The receiver dryer is, in other words, the unsung guardian of the entire AC system, and it has a finite lifespan, the history of automotive air conditioning. It goes back further than most people realize. The first factory-installed car AC system was introduced by Packard Motor Car Company in 1939, a bulky, expensive option
that took up most of the trunk and cost the equivalent of nearly $5,000 in today's money. For the next 2 decades, automotive AC was a luxury reserved for the wealthy. By the 1960s, manufacturers like General Motors and Ford had made meaningful strides in miniaturizing the technology, but the receiver dryer, the component that made all of this reliable, was already recognized as a consumable part from the beginning. The receiver dryer should be replaced anytime the refrigerant circuit is opened, and should be inspected and considered for replacement every 3 to 5 years regardless. This wasn't a secret. It was written into the foundational service documentation of the industry in 1992, the Society of Automotive Engineers. Technical standards for the entire global automotive industry,
published guidelines that explicitly identified the receiver dryer as a time-sensitive service component. A saturated or compromised receiver dryer is one of the leading causes of premature compressor failure and refrigerant system inefficiency. Once it absorbs a certain amount of moisture, it stops working. In fact, it does something worse than stop working. When silica gel becomes fully saturated and then subjected to the thermal cycling of a running AC system, it begins to break down, it releases moisture back into the circuit,
and it sheds fine silica particles that pass through the filter screen and circulate through the entire system, coating the interior surfaces of the expansion valve, the evaporator coils, and the compressor with a fine abrasive film. Think about what that means. You have a component that was designed to protect the system, and when it fails, it actively attacks it. The very particles meant to keep the refrigerant dry become a slow-motion contamination event that degrades every other component.
In the loop, and the timeline for saturation isn't decades, it's typically 5 to 8 years under normal use, or as few as 3 years in humid climates. High mileage applications, or vehicles that have had even minor refrigerant service work performed, every time a technician connects a service machine to your AC system, every time a fitting is loosened, every time a component is swapped, atmospheric moisture enters the circuit. It's unavoidable. The receiver dryer is supposed to capture that moisture, but if it's already partially saturated from years of normal operation, that small atmospheric exposure is enough to push it over the edge.
This is the part that nobody tells you. When you bring your car to a shop and say the AC isn't cold, the standard diagnostic procedure in most commercial repair environments
Involves checking system pressure, performing a visual inspection for obvious leaks, and connecting a manifold gauge set to read high side and low side pressures.
If the pressures are off, the easiest and most profitable diagnosis is low refrigerant, which means a recharge service, typically priced between $100 and $200. If the pressures suggest a bigger issue, the next step is usually to point at the compressor. What almost never happens is a deliberate inspection
Of the receiver dryer's condition, or a conversation about when it was last replaced, or a recommendation to change it as part of any refrigerant service.
Tact tiers. And the reason is almost insultingly simple. A receiver dryer costs between $10 and $18 for a quality.
The labor to replace it on most cars is between 30 and 60 minutes, depending on location and accessibility. The total cost of receiver dryer replacement, done properly, is somewhere between $60 and $120 at a fair shop, including labor. Compare that to a compressor replacement, which runs between $400 and $1,200.
Or an evaporator replacement, which can exceed $1,500 on some vehicles because of its location deep inside the dashboard, or a full system flush and recharge with leak repair,
Sections, which routinely lands between $300 and $600. The economic logic is not subtle. A $14 part that prevents $800 of future repair.
But a $14 part that, if ignored, eventually causes $800 of future repairs, that is a business model. Now, before I go further, I want to be honest with you.
About something, because you deserve the complete picture. The receiver dryer is not a magic solution to every AC problem. If your compressor is genuinely seized, if the clutch won't engage, if the pulley is grinding, if the compressor is pushing metallic debris through the system, replacing the receiver dryer alone won't fix that. If there is a major refrigerant leak at a hose fitting, an O-ring, or a damaged condenser, the system will lose refrigerant regardless of how pristine the desiccant is. There are real mechanical failures that require real expensive repairs, and anyone who tells you otherwise is doing you a disservice, but here's the critical distinction.
when a failed receiver dryer is the root cause, which diagnostic data and technician surveys consistently suggest accounts for somewhere between. In vehicles over 5 years old and it goes unaddressed, every other repair you do will eventually fail. You can put in a brand new compressor.
You can recharge the system with fresh refrigerant, you can replace the expansion valve, and within 1 to 3 seasons, the same symptoms will return.
It's because the contamination source, that saturated silica shedding desiccant cartridge, was never removed. This is how some repair shops generate.
They fix what's visibly broken, they just never fix what's invisibly broken. And that invisible broken thing keeps quietly destroying what they just replaced. So what does the fix actually look like? And on most vehicles, the receiver dryer is located on the high pressure side of the AC circuit, between the condenser, which is typically mounted at the front of the car, just behind the grille, and the expansion valve. It's usually attached to the condenser directly,
or connected via short refrigerant lines nearby. On some vehicles, you can see it without removing anything. On others, it's tucked behind a splash shield or an air duct. But still accessible without major disassembly, and the process begins by having the refrigerant professionally recovered. Because under EPA regulations and environmentally damaging, a certified shop or mobile AC service can recover and store your refrigerant for a small. Once the system is empty, you disconnect the refrigerant lines from the receiver dryer, usually 2 fittings, often held by snap ring clips or small bolts.
remove the 1 or 2 mounting brackets securing the unit to the vehicle, and pull it out. The new unit goes in,
The fittings reconnect. Fresh O-rings are installed at every connection point, and the system is evacuated with a vacuum pump to remove any remaining atmospheric moisture before being recharged. When done correctly, with a new receiver dryer installed and all O-rings renewed, a system that was blowing lukewarm air at 72 degrees spare vent temperature can return to blowing air at 38 to 42 degrees Fahrenheit, which is the performance standard for a properly functioning automotive AC system. That's not marginal improvement.
That's the difference between suffering through a summer and not noticing the heat at all. The vacuum step matters enormously and is often rushed or skipped in commercial settings. Pulling the system down to at least 500 microns of vacuum and holding it there for 30 minutes removes dissolved moisture from the oil and the metal surfaces. Of the components, it costs nothing in materials, it takes time, and time is what repair shops manage carefully. What you're looking at, in the end, is a repair that costs between $70 and $150 if you hire it out to a knowledgeable independent shop, or as little as $30 to $50 if you own a vacuum pump and can do the physical swap yourself using a mobile refrigerant recovery service against the backdrop of a $900 compressor job.
It is almost absurd how small that number is, and yet this conversation almost never happens at a dealership service counter. There is a broader pattern here
that goes beyond car air conditioning, and you already sense it. The history of practical maintenance, of machines, buildings, and systems of every kind, is full of small, inexpensive, consumable components that serve as the guardians of much larger, more expensive systems. The water filter that protects a $400 refrigerator compressor, the fuel filter that protects a $700 fuel pump. They are sacrificial by design. They absorb the punishment so that the expensive components don't have to. But somewhere in the evolution of consumer automotive culture,
somewhere between the rise of dealership service departments in the 1980s and the consolidation of chain repair shops in the 1990s and 2000s, the economics of maintenance shifted.
The consumable parts that should be proactively replaced were replaced instead by diagnostic frameworks that wait for symptoms, identify the most expensive plausible cause, and generate repair orders that maximize revenue per vehicle visit. This isn't a conspiracy. It doesn't require anyone to lie. It only requires a system where the incentives
are structured so that identifying a $14 root cause is less profitable than treating a $900 symptom, and in that system, the receiver dryer became invisible. Not hidden deliberately, just quietly de-emphasized until it fell out of the injured conversation entirely.
The SAE published guidelines about it. Old school mechanics who trained in the 1970s and 1980s, the ones who worked on Freon-based R12 systems,
will often tell you immediately that the dryer should be changed with every service. That knowledge exists, it's just not being passed forward in commercial repair environments.
Where efficiency, throughput, and ticket averages matter more than complete diagnosis, you now know what most people who've paid for multiple AC repairs still don't know.
You understand why the system fails, you understand what the component actually does, you understand why it's ignored, and you understand exactly what to ask for the next time.
Someone tells you your compressor needs to be replaced, ask them when the receiver dryer was last replaced, ask them if they checked the desiccant condition. Ask them whether the system was properly evacuated before recharge. Those three questions will tell you immediately whether you're talking to someone who actually understands your AC system or someone reading from a diagnostic script that ends at the most expensive line item. The knowledge that keeps machines running well has never really been complicated.
It's been made to feel complicated. It's been surrounded by jargon, by specialized equipment, by the implied authority of people in uniforms holding clipboards.
But the actual physics, the actual chemistry of a car AC system is something any person can understand in 20 minutes. And once you understand it,
you can't be overcharged for it. That's the real value of what you've just learned, not just a $14 fix, not just one repair saved.
It's the shift from being a passive consumer of a system that profits from your ignorance into someone who understands what's actually happening under the hood.
Someone who can ask the right questions, make informed decisions, and recognize when a diagnosis is designed to serve you versus when it's designed to serve the shop.
Your car's AC was probably not dying, it was probably just thirsty. Thirsty for a small cylinder of fresh desiccant that costs less than a fast food